Now, how do we calculate the derivative? So we will be looking now at the calculation rules for derivatives. Assume that we have c is a constant and a real number. And we have two functions, f and g, which are differentiable. The derivative of a constant function so for the derivative of a constant, we have that if f of x is c, then f prime of x is 0. So the derivative of a constant is always 0. The proof is very easy. You just take the formula for the derivative and you plug it in. So f prime of x is f of x plus h minus f of x divided by h, and then the limit for h to 0. Then we have the limit h to 0. F of x plus h is just the constant c. F of x is also the constant c. So we get very easily that this is equal to 0. Next, there is the power rule. So the power rule basically tells me what to do if my function f of x is x to some power n, where n is positive and a natural number. So in this case, my derivative will be n times x to the power n minus 1. So you multiply with the original power, and then you have x to the power n minus 1. Again, for the proof, we take the formula and we plug it in. So plugging this in is the limit for x plus h to the power n minus x to the power n over h to 0. This is the limit h to 0, where we use the binomial theorem, which we will see in a next chapter. So this is k equal to 0 to n, so the sum over all those of the combination of k out of n, x to the power k, h to the power n minus k, minus x to the power n over h. So here the red part, what we use is the binomial theorem. And as I said before, we will see this in a later chapter. For now, what you need to know is k out of n. So this is the combination of k out of n is n factorial divided by k factorial times n minus k factorial. And here, n factorial is just n times n minus 1 times n minus 2 and so on until 1. So it's just the multiplication of n with every number that comes before. So this is called n factorial. So the formula we had, the last formula from the previous slide, was the limit for h to 0 for x plus h to the power n. So the binomial theorem applied, the sum over k is 0 to n, a combination k out of n times x to the power k, h to the power n minus k, minus x to the power n divided by h. If we then look at the term where k is equal to n, so if k is equal to n, this is n out of n times x to the power n times h to the power 0. N out of n is n factorial divided by n factorial times 0 factorial times x to the power n. The first one is just 1, so this is x to the power n. So this x to the power n will be cancelled out with the other one, with the minus x to the power n. So what we have is the limit h to 0. The sum k is 0 to n minus 1, because the last one will be cancelled out. K out of n, x to the power k, h to the power n minus k divided by h. Then every term has a factor h, so we can divide out one of the h's. So it's the limit h to 0. The sum k is 0 to n minus 1, k out of n, x to the power k, and then we divide out one of the h, so it becomes h to the power n minus k minus 1. what we see in this last equation is that you have h to the power n minus k minus 1. In the limit for h to 0, this will always be 0, unless we have h to the power 0, which is 1. So unless n minus k minus 1 is equal to 0, or k is equal to n minus 1. So if I take my limit for h going to 0, the only term that is left is the one for k equal to n minus 1. So it's n minus 1 out of n times x to the power n minus 1. This is then n factorial over n minus 1 factorial times 1 factorial times x to the power n minus 1, which is, if you write it out, just n times x to the power n minus 1. We also have the general power rule, which is basically the same thing as the power rule, except that now my power can also be a rational number. So f of x is x to the power n, but n is this time a rational number, so it is in Q, n still not equal to 0. Then f prime of x is again n times x to the power n minus 1. The proof of this will be seen in the exercises, so you will do the proof during your exercise session. We will make an example. So for example, if f of x is x times the root of x, then what is the derivative? So this is also the same as f of x is x to the power 3 over 2. So f prime of x, the derivative, is 3 over 2 times x 3 over 2 minus 1. So it's 3 over 2 times x to the power 1/2, which is the root of x. Next up is the constant multiple rule. So we have c a constant. We defined that as before f is differentiable. So let's write it down. So if c is a constant and f is differentiable, then the derivative of c times f of x is just c times the derivative of f of x. Proof. So let's call c times f of x g of x. And so we have to find the derivative of g of x. So g prime of x is the limit of g of x plus h minus g of x over h. So it's always the same thing, always plugging into the formula for h to 0. So this is the limit of c times f x plus h minus c times f of x divided by h. We can take out c, so it's just c times the limit. We saw in limits that we can take out a constant. So h to 0, f of x plus h minus f of x divided by h. And this is just a formula for the derivative. So it's c times f prime of x, which is what we had to prove. Then there's also the sum rule. So f and g are differentiable. Then the derivative of the sum, so we have f of x plus g of x. If we derive this, it is just the derivative of x plus the derivative of g. The proof is trivial and is left up to you to try. So with these rules, what you can do, you can already derive every polynomial. Because a polynomial is just a sum of terms of x to some power multiplied with a constant. So with the previous rules, you can derive every polynomial already. So let's say we have any polynomial x to the power 8 plus 7x to the power 7 minus 3x to the power 6 plus 4x to the power 3 minus 2x minus 7. And let's say we want to derive this. Then we know that the derivative of this it's a derivative of a sum, so it's a sum of derivatives. And then for each of those separate derivatives, you apply the rules with taking the constant out and lowering the power. So this will become 8 times x to the power 7 plus x to the power 7 derived is 7 times x to the power 6, so it's 49 x to the power 6 minus 18 x to the power 5 plus 12x squared minus 2 minus 0. So this is the derivative of the polynomial. Very trivial, very easy to see. Another very easy formula is the formula for the natural exponential function. So if we derive e to the power x, it is just e to the power x again. Also for this one we will not see the proof. Let's then look at the product and the quotient of two functions. So let's start with the product. So the product rule. We have two functions f and g. They are both differentiable. Then, if we take f of x times g of x, and we want to derive this, this is the derivative of x times g plus f times the derivative of g. For the proof, what we do again is we set this f of x times g of x that we want to derive. We set this equal to some new function f of x, and then we calculate the derivative of capital F. So this is the limit for h to 0 of capital F x plus h minus capital F x divided by h. We then plug in the formula, so the limit of f x plus h times g x plus h minus f of x times g of x divided by h for h going to 0. In the next step we will insert some extra terms which will help us calculate this derivative. So f of x plus h g of x plus h minus f of x g of x divided by h. And now we will add and subtract f of x plus h times g of x. Why do we do this? Because now we can take two terms together and bring always some common part out of it. So let's do this. So this is the limit h to 0. You take the first two terms together, so the common factor is f x plus h, and then you get g x plus h minus gx. And for the other one, you can take out g of x, and you get f of x plus h minus f of x. So this already starts to look like the derivative of f and the derivative of g. Then we apply calculation rules for the limit. So we know that the limit of a sum is a sum of limits, and we also know that a limit of a product is a product of limits. So let's say this is the limit of f x plus h times the limit of the other term, so g x plus h minus g of x divided by h. And for the other one the same, so it's plus the limit of g of x for h going to 0 times the limit f x plus h minus f of x divided by h. Then here you know, or you can use that f is differentiable. So this also means that f is continuous. And if f is continuous, it means that my limit function has to be equal to my function value. And so the limit f of x plus h for h going to 0 is just f of x times what we have here is the derivative of g plus the limit g of x for h going to 0. There is no h dependency, so this is just g of x times f prime of x. And we found the formula that we wanted to prove. So if you have a product rule, you will also have a quotient rule. Again, f and g are differentiable functions. Then you can look at f of x divided by g of x, and you can derive this one. So this is f prime of x times g of x minus g prime of x times f of x divided by g of x squared. The proof of this formula will be seen also during the exercise sessions. And then you have a corollary, namely that the derivative of 1 divided by f of x, this one, is minus f prime of x divided by f of x squared.